Hi everybody, welcome back. We're on lesson 7 today on simplifying expressions. Your learning targets. When you are done with this video, you will be able to combine like terms and use some special properties to simplify expressions. Got a few of those in the slide there. Let's talk about the commutative property. The commutative property allows you to add or multiply numbers in any order. Okay? So when we're dealing with the commutative property, we're dealing with mixing up the order. The order doesn't matter. So the commutative property of addition says that if you add two numbers, a plus b, it's the same as adding them in the opposite order, b plus a. And you already know that to be true. You've worked with that a lot. The commutative property of multiplication says if you multiply two numbers, a times b, that's the same as b times a. Okay? So here's an example. 3 plus 5 is the same as 5 plus 3. You get 8 on both sides. 3 times 5 is the same as 5 times 3. They're both equal to 15. That's the commutative property, changing the order of which one comes first. The associative property allows you to group numbers differently. Okay, you're associating numbers together. So the associative property of addition says that if you add two numbers together, the first two, and then add the third, it doesn't make any difference. You could add the first number to the sum of the last two. Okay? Same thing with multiplication. It doesn't matter how you group them together, you will get the same answer. So here's an example. If I group the first two in 2 plus 3 plus 4, that's the same as if I group the last two, 2 plus 3 plus 4. Well, 2 plus 3 is 5. 5 plus 4 is 9. Over here I get 2 plus 7, and 7 plus 2 is 9. So you can see that I get the same thing. Likewise with multiplication, if I group the 2 and the 3, I get a 6, and a 6 times 4 is 24, right? But if I group the last two, I get 2 times 12, which is still 24. That is associative property. We're grouping differently. Now the distributive property is completely different from the commutative and associative properties. The distributive property allows us to get rid of parentheses. So one thing to note is that the addition and subtraction must be inside the parentheses, and the multiplication is done on the outside. Okay? So whether we have numbers that are added or subtracted, what happens is we distribute what's on the outside through the parentheses. So instead of a times b plus c, we get a times b plus a times c. And then on the right-hand side, a times b minus c, when we have a difference of two numbers, we end up with ab minus ac. Now I know this gets confusing over on the right-hand side when some of these numbers are negative, so hang in there. We'll talk about that. So the first example, 2 times 3 plus 4. The distributive property says we're going to go ahead and multiply 2 times 3, and then add that to 2 times 4. 2 times 3 is 6. 2 times 4 is 8. 6 plus 8 is 14. Okay. On the left-hand side, if we go ahead and use our order of operations, we would get 2 times 7, which still gives us a 14. Over on the right-hand side, why don't you pause the video and do this one on your own? All right, here's what you should have got. 2 times 5 minus 2 times 3, which is 10 minus 6, which is 4. Hopefully you got that right. So the distributive property, one of the really cool things that the distributive property does is it helps us to do mental math. Yay! Everybody loves to do mental math. So this is actually pretty cool because you can do these multiplication of big numbers in your head just by using the distributive property. And I love this. So what we can do is write the number 52. I'm going to write that as 50 plus 2 because those numbers are easier for me to multiply in my head, right? And we have a 9 on the outside. Well, the distributive property says we take 9 times the first one and then add 9 times the second one, right? Well, 9 times 50, 9 times 5 is 45, add a 0. 9 times 2 is 18, add those together, and that gives us 468. So, actually, you could do that in your head, right? 9 times 50, and then 9 times 2, and add the numbers together. 14 times 98. Well, now I'm not going to do 90 plus 8. This one's really close to 100. So this one I'm going to do a subtraction. 100 minus 2. How about that? Well, 14 times 100 is 1400, right? 14 times 2 is 28, and we're going to subtract that. So we're going to be a little under 1400. It's going to be 1300. And what's 100 minus 28? Well, we know it's going to end at a 2, right? And that's probably going to be a 7, 1372. So you can do it in your head. Pretty cool, huh? So let's identify what properties are being used in these problems. So which property is it that tells us that 1 times 4 is the same as 4 times 1? What did we switch? Did we group? Did we get rid of parentheses? Did we switch the order? And you're right, we switched the order on that one. So that is the commutative property. What did we do on this one? Did we switch the order? Did we associate? Same thing, commutative property of addition this time. This one was multiplication, this one's addition. What's going on here? A little bit confusing because I kept the parentheses in there, right? Hopefully you recognize that one as the distributive property. Letter D, 2, 5, 4, 2, 5, 4. So the order is the same, right? So we didn't switch the order of anything, so it can't be commutative, but we're grouping them differently, so that's the associative property. And the last one, 7, 1, 3, 1, 7, 3, we switched the order, didn't we? So we're still adding the same two numbers together, but we switched the 1 and the 7. So that one is the commutative property. Here's some more practice for you. Some cool things here. I'm going to show you 4 times 9 times 25. So these three are multiplied together so we can use our properties. We don't have any parentheses. But I think if we do 4 times 25 and then take that times 9, we can do that in our head. Okay? Hopefully you recognize 4 times 25. If you have 4 quarters, you have $1, right? So that's 100 times 9, and that gives us 900. Okay, no calculator needed. Letter B. Okay, would you use distributive on this one to get rid of the parentheses? Or would you add these two first? And I think I would add these two first. 12 plus 8 is 20, right? What's 20 times 20? Hopefully you recognize that as 400. And it's a negative times a positive, which is a negative. Okay? Letter C. 6 times 2 minus 7. This one could go either way. I think I would still do what's in the parentheses first. Okay? If you were using your properties, I'll do it both ways. I'll just show you. 6 times 2 minus 6 times 7, right? Well, this is 12 minus 42. And let's see, 42 minus 12, because they're opposite signs, gives us 30, but it must be negative. Okay, now this one you could also do is 6 times 2 minus 7 is negative 5. Probably a lot easier this way, right? Negative 30. Doesn't matter which way you do it. Same answer. Letter D, I would mix this one up. Letter D, I would go ahead and take the 1/3 times 21 times 8. Okay, 3 goes into 21, so I would put this one over 1. And we can cancel, right? 3 goes into 21 7 times. 3 divided by 3 is 1. So we end up with 7 times 8, which is 56. And our last slide, like terms. Terms are like terms if they have the same variable with the same exponent. And like terms can always be combined. So our directions say simplify by combining like terms. Well, are these like terms? Are 15x and negative 3x like terms? And the answer to that question is yes. The variable is the same. They're both x's and they're both to the first power. So we have a negative 3x and a positive 15x. Opposite signs, subtract. 15 minus 3 is 12. Keep the x. 15 is bigger, so my answer is positive. 4p cubed minus p cubed. Are they alike? Are they like terms? Well, the variable is the same. The exponent is also the same. So if I have 4p cubes minus a p cubed, remember the coefficient here is 1, right? So 4 minus 1 is 3, and you keep the variable exactly like it was. Letter C. Well, we have a lot of things going on in letter C. One of the things you might want to do is to use a highlighter or a marker or you could circle terms that are alike. So I know this one has an x, this one has an x, and this one has an x. So I'm going to go ahead and combine those together because those are like terms. So when I do that, 12x minus 5x is 7x plus x plus 3a. Well, this is the same as how many x's? That's 8x plus 3a's. Now these are not like terms, so that's as much as I can do to simplify. Over on the right-hand side for letter D, we need to get rid of our parentheses. So what property was that? That was the distributive property. Okay, and the distributive property says you multiply everything inside the parentheses by whatever's on the outside. So that says take 2 times x, add to that 2 times 3, which is 6, and then on the outside we still have plus 7x. Well, which of my terms are alike? Well, I have the 2x and the 7x are like terms, so I need to combine those together. So 2x and 7x gives me 9x, and then I still have a plus 6. The 6 does not have an x, so it does not combine with the 9x, and that is your simplified answer. That's it. See you next time.